Hello class, these are our Algebra 1 notes for sections 4.4 and 4.5 using function notation to describe rules. So the first couple examples we're going to look at are involving translating words into algebraic functions. So translate each written phrase into an algebraic function. That means we're going to take words and we're going to write math. So to get the output of function f, add 2 to the input, then multiply the result by 5. So to get the output of f, so output of f, that means f of x. So they're telling us what it's equal to. We add 2 to the input. That means my input is x. I need to take x and add 2. And then I want to multiply that entire result by 5. So if I want to take all of this and multiply by 5, then I have to put in parentheses. And I could put a times 5 at the end. But we're really just used to seeing the 5 being multiplied in the front of the parentheses. The second one says to get the output of the function m, so that means m of x equals, multiply the input by 1/2 and subtract the result by 3. So if I want to take my input, my x, and multiply by 1/2, that's going to be 1/2 x. It says take that and subtract 3. So I have to decide if I want to take this entire thing and subtract 3, do I need parentheses? And I don't, because order of operations is going to have me multiply first. So I do not need to write my parentheses. I could just write the 1/2 x minus 3. Next, we're going to look at functions as tables and graphs. We're buying apples at the local market at a cost of $2.99 per pound. Translate into function notation. So sometimes I think it helps to kind of make a table of values first. I'm actually going to start with B. So X is going to be my pounds. That's going to come first. I pick out my pounds of apples, and then I pay based on the amount of apples I buy, right? So it's not like I go in, give them $5, and then pick out apples to make $5. I weigh my apples, and then I pay for that amount. So if I buy 0 pounds of apples, I pay $0. 1 pound of apples would be $2.99. 2 pounds of apples would be $2.99 times 2. That's $5.98. 3 pounds of apples would be 3 times $2.99. That's $8.97. If I wanted to buy 4 pounds of apples, well, 4 times $2.99 would be $11.96. So for each of those, I took my number of pounds and I multiplied it by my cost per pound. So my cost is going to equal $2.99 times my number of pounds, which is X. So sometimes it does help to come up with some examples first. Then we want to graph. So I'm going to have my apples as my x-axis, pounds of apples, and this is my cost of apples. And I think there's enough lines to label like every 2. And we'll do the same thing for the y-axis. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 0, 0. 1 pound is about $3. 2 pounds is about 6. So we're definitely doing some rounding here. 3, 4, 5, 6. 3 pounds is about $9. And then 4 pounds would be about $12. So let's go ahead and connect. And the reason I can connect my graph is that all the points between those make sense. I can buy 1.5 pounds of apples. I could buy 2.4 pounds of apples, right? So this is a linear function. Because the value of the function changes by a constant rate. That's my slope, that's the $2.99, and the graph is a line. So for the next couple, we're going to look at some things written out in function notation. So function notation just means I'm using that f of x instead of the y. So when I graph, I'm really just graphing y equals x minus 4. So just like always, my y-intercept is going to be 1 to negative 4. Let's see right there. And my slope is 1 over 1. So I'm going to go up 1 and then 1 to the right from that point. So we start at our y-intercept and then we graph our slope. I could move down 1 and 1 to the left as well and continue that pattern. So let's just label really quick. So my slope was 1 over 1. My y-intercept was 0, negative 4. Let's do the same thing on the next one. F of x just really means y equals 3x. There's nothing after the x, so there's a plus 0, so I start at 0, 0. That's going to be my y-intercept. And then my slope is going to be 3 over 1. I can always make a whole number and put it over 1. So up 3, 1 to the right, and I'm going to keep making that slope. I could also go down 3, 1 to the left. These are points on the same line, and I can connect again. Last one, same thing. When they're talking about f of x, we really mean y. So y equals 4/5 x plus 2. So my y-intercept is going to be 0, 2. And then my slope is the 4/5. So that means I need to go up 4 and 5 to the right. I think that's right. I'm having a hard time counting this out and seeing today. 1, 2, 3, 4. I think it's right here. 1, 2, 3, 4, 5. All right, there we go. So next we're evaluating a function. If f of x is 5x minus 7, find f of 6. So notice that the 6 is in the parentheses where the x is. Okay, so that gives us a clue as to what we're doing. We are going to sub 6 in for x and simplify. So that means f of 6 is going to equal 5 times 6 minus 7. Now the part I want to go through and simplify is just the part on the right. So that's going to equal 30 minus 7, which equals 23. So what I have here is f of 6 equals 23. That tells me I have a function, my input is 6, my output is 23. So all of that is part of our answer. It doesn't mean f times 6. We are not dividing or subtracting 6 on both sides now. We're done. Same steps on the next one. I have negative 4 in my parentheses where my x is. That means I'm going to let the x equal negative 4. And so everywhere I see an x, I put in a negative 4. Make sure you have your negative 4 in parentheses when we're squaring it. Remember, it's not the same if we don't have it in parentheses. So negative 4 times negative 4, we would do exponents first. That's a positive 16. And then I would multiply left to right. So 3 times 16 is 48. And then 2 times negative 4 is negative 8. And 40 plus negative 8 is going to be 40. And so g of negative 4, my function g, when my input is negative 4, is going to be a positive 40. Last two, we're solving for x. So this is a little bit different. They're not telling me what to put in for x, and it doesn't have a number in front of parentheses. It says h of x is equal to 9. That means my 9 is going to get substituted in for the h of x. So I want to sub in for h of x, then solve for x. So it's definitely worded differently than before. So I'm going to write 9 equals 8x minus 7, and then we're going to solve. So add 7 on both sides. 16 is equal to 8x. Divide both sides by 8, and 2 is equal to x. Next one, same thing. It says j of x equals 42. It doesn't say j of 42. It says j of x equals 42. So the 42 is going to go in for all of j of x, and then I'm going to find x again, solve for x. So 42 equals 4 times x minus 5. And then I think my first step on this one would be to distribute. So 42 equals 4x minus 4 times 5 is 20. Then I would want to add 20 on both sides. So I have 62 is equal to 4x. And then I would divide both sides by 4. Now 4 doesn't divide in evenly, but they are both even numbers. So I could simplify by dividing the top and bottom by 2. So that means I have 31 halves is equal to x. And that's a great answer. We can leave our answers as fractions. So the big thing here is just this difference between finding f of 6 and then finding like h of x equals 9, right? Those are worded differently. One of them is just like having that f of x. It tells me that my x is 6. The other one, I am not given x. I'm given this value, this h of x, and I have to solve. It's a little bit tricky. Lots of ideas today about this function notation. As always, if you need help, please make sure you ask.